This video will cover the top flap of section number 3 in your Unit 7 Similarity Flipbook. Top flap of section number 3. The name of this flap is Transformation Notation. And here is our essential question for this video. How do I use transformation notation to describe a transformation? Now you're going to have to write these things in your flipbook right now. So first column, if you will label that as translation, second column reflection, third column rotation, and fourth column is our new transformation that we're learning in this unit, and that is dilation. So translation, reflection, rotation, those we've covered in a previous video and we learned those last year. Those all will create a congruent image. Translation means we slide it, reflection means we flip it, rotation means we turn it, but in each of those cases we end up with a congruent image. It's identical to the pre-image. Dilation is a little bit different. So let's go ahead and do some examples here. I'm going to go ahead and narrow this down now so we can look at just the first column, translation. Here's an example of a translation written in transformation notation. If you took your original coordinates and you translated them so that your x values become x minus 2 and your y values become y plus 3, you're actually going to take your shape or whatever your image is. We're going to slide it because this is a translation. We're going to slide it left 2 units and up 3 units. So because our x values are being reduced by 2, it's going to move our image to the left. And because our y values are being increased by 3, it's going to move the pre-image, going to move the pre-image left 2 units. And because our y value is being increased by 3, it's going to move our pre-image up 3 units. So our new image is going to be 2 units to the left and 1 unit up. Here's an example of that. Let's say on a coordinate plane we have a point, and the point is at 6, -3. If we translated it based on this transformation notation, we would end up with the x value being 6 minus 2, which is now 4, and our y value, which is -3 plus 3, that ends up being 0. So this point would move to 4, 0. Here's another example of a translation. In this case, take a look. We are going to, again, we're translating, so we're going to slide. In this case, the x value doesn't change, so we're not going to move left or right on the coordinate plane. Our y value is going to be decreased by 1, and that means we're just going to slide our pre-image down 1 unit. An example of that would be, let's say we had an original coordinate 6, -3. If we translated it with this translation, the x value is going to stay the same, and the y value is going to go from -3 to -3 minus 1, which is -4. And that would create a new point that is 1 unit below the original point. So there are some examples of transformation notation when we're translating a point, or a vertex of a polygon, or a point on a coordinate plane. Let's take a look at reflection. Here's some examples of reflection. Remember, reflections are flipping. So in this case, we're going to take our original x value and y value. The x value is going to stay the same. The y value is going to change to negative. Now think about this. If you look at this example on a coordinate plane, if we have an original point on here, let's say it's at this point right here, if the x value stays the same, then we're going to still stay on this vertical line. The y value is going to change to negative, and that means it's going to move down to here. So because we're going to move this direction, we're actually crossing over the x-axis. So this particular transformation notation is a flip across the x-axis. Now it doesn't look like that because the y value is changing, but it's a little deceptive. If you ever wonder what it is, class, just sketch a coordinate plane, put a point anywhere on there, and pretend the x value is going to stay the same when the y value is going to change sign, and you'll see it's actually flipping across the x-axis. Here's an example of that. Let's say we have the point 4, 3, and we're going to translate it with this reflection. The new coordinate is going to be, well, the x value stays the same. That's going to be 4. The y value flips to the opposite sign. It's going to be at 4, -3. Here's another example of a reflection. In this case, we're actually flipping across the y-axis. You can use the same method as I did here. You can sketch a coordinate plane and take a look and see, well, let's just pretend that we had this point right here. Let's put a red point on here, and let's just pretend that the x value changed to negative. That puts it over here, and the y value stayed the same. Well, that ends up being a reflection across the y-axis. Here's an example of that. Let's just say we had a point on a coordinate plane. Could be a vertex of a triangle or a square. Any point on a coordinate plane. Let's say it started off as 4, 3. If we ran it through this transformation right here, we would end up with -4, 3. Because our x value changed sign, our y value stayed the same. Alright, one more. Let's do rotation. What's rotation look like? Well, rotation is turning. So in this case, if we look at this again, this is the one that gives students the most problem. This is actually a turn 90 degrees clockwise around the origin. Around the origin, or at 0, 0. Again, if you wanted to see how that works, you could just sketch a coordinate grid, and let's just say, let's put a pretend point on there as xy. So what's going to happen here is the y value is going to become the x value, and the x value is going to become the y value, but it's going to be negative. So what's going to happen is your point's going to end up somewhere over here. So you can see that as a rotation, not a reflection. It's actually going to change a little bit. It's not going to be straight across the x-axis. It's a rotation around the origin. So let's take a look at an example of that. So for example, let's say that we had a point 2, 3. If we run it through this translation, it's going to now become, the y value was 3, that now becomes the x value. And the x value was 2, that now becomes the y value, and the sign flips. So our new point would be at 3, -2. One more example. xy translates to -y, -x. That's actually a turn 180 degrees around the origin. Notice I didn't have to say clockwise or counterclockwise, because when you rotate something 180 degrees, it ends up being the same whether you go clockwise or counterclockwise. So this represents a turn of 180 degrees around the origin. Here's an example of that. Let's say your original point was at 2, 3. If we translate it with this particular translation, the x value becomes the y value, but the sign flips, and the y value becomes the x value, and the sign flips. So there would be our new point. That's rotation. One more now, our new one. How do we use transformation notation to describe a dilation? So dilation, if you remember from our previous video, dilation is going to enlarge an object or reduce an object. It's going to look exactly the same shape, it's just going to get bigger or smaller. So take a look at how this works. This xy is now going to become 3 times bigger than it was before. So now this is actually describing an enlargement, and the ratio is actually 3 to 1. 3 to 1, because the pre-image is getting 3 times bigger when we make the copy and turn into the image. So the pre-image is going to be a certain size, the image or the copy will be 3 times larger. Here's an example of that. Let's say that we had a point 4, 3. If you run it through this transformation, you're going to get 3 times 4, which is 12, and 3 times 3, which is 9. So our new coordinate would be at 12, 9. Here's another example of a dilation. In this case, this is going to be a reduction. The pre-image is going to shrink because now our numbers here are going to be smaller. If x was 4, it's going to be 1/2 of 4, or 2. If x is 6, 1/2 of 6 is 3. This is a reduction. This is actually a reduction of a ratio 1 to 2. Now notice where these come from. The 3 to 1 came from the fact that 3 was tagged onto the x and the y. The 3 can be written as a fraction of 3 over 1, which is 3 to 1. The 1/2 can be written, of course it's a fraction 1 over 2, can be written as 1 to 2. So our scale factor, or how much our image is going to change in size, is directly related to this number here, our multiplier for x and y. So in this case, let's get an example. Let's say we had an original point at 4, 6. If we run it through this reduction, this translation here, or sorry, transformation, we're going to end up with 1/2 of 4, which is 2, and 1/2 of 6, which is 3. Our new point will now be at 2, 3. So there are 4 examples, or actually 8 examples, of how we can use transformation notation to write or describe a translation, a reflection, a rotation, and a dilation.